The aim of this video is to document and show to myself of the future, to my kids, to you all, my design process. I'm gonna design a new Lego Boost model. So this is the list of models that I have designed in the past and something that I still have to design. Sometimes my speech won't be too smooth because this is not my native language. I would prefer making this in Italian, but for the public, I'm trying to make this in English as best as I can. Again, with Lego Boost. So with this hub, the external motor, the sensor, and a lot of parts coming in the Lego Creative Toolbox, Lego Boost Creative Toolbox number 17101. From this list, I asked my kids to, well, we made a poll, and drum roll, like it or not, the winner was the helicopter. I'm gonna start sketching something to make this a little more successful than just starting with something from scratch, because starting with a sketch is useful to save up time later on. So the first step when I design something is usually making some research in terms of looking around the web and see if someone has already done something similar. In case of a Lego design, it's always useful to check out what Lego did in terms of official sets, especially Lego Technic official sets. So the first thing I would like to do is going and search for Lego Technic helicopter to get a taste of what's been done in the past. There is this recent one, the Airbus H175, which is pretty complex, and this other one, the 9396, or a one that well, there are a ton of them. So this to get an idea, and then besides that, there are some simpler one, some most complex one, and the first Lego Technic set I got was actually an helicopter, a very simple one, and one I loved was, let's see if it was a black one back in, no, I had this one, the 8412. So I get inspiration from the web, also from other designers, of course. Just getting inspiration, not copying whole stuff, of course. I have to take into account what I have in terms of motors, the hub itself, to get the overall shape for this thing. So this is bulky, this is huge, and I have to take this shape into account to develop something. So the idea here is getting a helicopter made around this huge hub. I don't know if I will put these are two embedded motors, two built-in motors. I cannot do anything about this. So in any case, I need to access this button, even if I cover this up and with a lever or something. And I would like to use these two motors to do something, maybe open and close cargo bay here, lower and raise a crane or something. Or I don't want this helicopter to shoot anything because I really despise shooting devices, something that recalls war stuff and so on. And I think I will use this motor, which is more versatile in terms of orientation or placeability on the model, to power the propeller and the back propeller. So the idea here is to place it somewhere, maybe here. So these are the parts. I will place it here and have some gearing to, I don't know if you can see anything. Maybe I have to zoom a little bit, sorry, and change the pen maybe, but I will make it better later. And have the same axle, I can make it longer with joiners, and have another gear here to power up the propeller. I want this propeller to be fast, but not that much, because if it's too fast, the risk is it can become dangerous. And since I am designing a toy and not something that has to fly for real, I have to be very careful about it. And then here, well, this is too short, so imagine this is longer. Let's design this to be longer, because I want something which is also good looking, not just functional. I can have something here like this to represent the tail of the helicopter. Let's design a sort of cockpit here of some kind, and have the skids, how do you call them? I don't know. So that's the basic sketch. That's the motor. I have to find something that is curved here, and we could have, how about this? We could use this to open and close a cargo bay on the back to release some water. Could be a firefighting helicopter. And on the other side, we could have some sort of crane to hook up something. That's an idea. I don't know how it will evolve, so let me just refine the drawing so you can see it better. And now, okay, so we have the hub. The other motor will have a sort of gearbox here. We will use bevel gears to transmit the movement at 90 degrees, and here we'll have the propeller, the main propeller, and then this goes straight to the back, and here and again a bevel gear with the back propeller, which is used to prevent the whole helicopter from spinning in the opposite direction than the main propeller. And then, oops, the pen. And then two motors here. We have the parts here, one for the motor, and here we will have the skis. How do you call that? I don't know. The cargo bay that can open, and here a crane that might go down, can have some sort of tool. Another addition, a nice addition, and I have to credit Lego YouTube, a YouTube creator, which I don't remember the name, I will write it somewhere, that this idea of having the color sensor pointing down to measure the distance from the floor, the ground, and we could make this propeller spin faster as the helicopter takes off, so you can lift it up and have it sorry, it was all out of focus. Have the helicopter propeller spin faster as it gets higher from the floor, and we could also have something reacting to the tilt of the whole hub. So that's the hub. We have 1, 2, 3 holes here, another hole here. That's the part. These are the motors, one on the one side and one on the other. And I have to find a way to press the button, which is right here, which is the this is the external motor, and this is the color and distance sensor pointing down. So let's see how to start from here. So that's the basic idea. So we'll try to stick to this as much as we can. Designing using a particular assortment of parts is a constraint which, in my case, helped my creativity. In case I want to design something out of a particular assortment of parts, in this case the Lego Creative Toolbox, I have to stick with the parts I have in the set. So that requires you as a designer, as an AF, or as an hobbyist to know very well the parts you have. In this case, besides the hub, the motor and the sensor, I have a lot of parts, and this set was criticized sometimes because it has too many parts, and in some terms it's true, there are many, and so you need to first of all sort them out to understand what you have to work with. In this case, I divided them like so. I put some Technic bricks here, the long one, the short ones, the frames, Technic beams, all the other Technic pins, gears, cross blocks, whatever, threads, wheels, sprockets, and there are the wheels, they should be here. The empty buckets are the ones of the electronic parts, so I usually store the motors and sensors here. Then I have plain bricks, tiles, plates, 1 by something plates, 2 by something plates, longer plates and Technic plates with the holes. And then I have large plates, miscellaneous stuff, joints on strange things that I rarely use. And then big round pieces, small round pieces, big slopes, no, small slopes, sorry, these are the small slopes, very large decorative elements, and here all the snot bricks, which are not just to make something that looks cool, but also they are a key to make models which are strong. So I use them very often to reinforce the buildings, to make something that doesn't fall apart as soon as you pull it slightly. So having the parts here is not enough. I don't know the exact numbers of all the parts in the set, but if you ask me, for example, how many white slopes of this kind you have in the set, I know there are 11. And in case you don't remember everything, it is useful to have a list of the parts included in the set, which is a key to know if you are, for example, running out of a certain type of element. This is crucially important to know, because otherwise you run out of parts, and if you know this before beginning, you will save time later. Let's move on. Latins called the horror vacui, the horror of vacuum, of empty spaces, or the blank canvas terror, or whatever you want to call it. The fact that you feel in difficulty when you have a blank sheet to fill with drawings, in this case a model that has to be made from scratch, in this case our helicopter. So in case you want to get inspiration, there are some, well, I wrote this book, so I wrote some notes to myself. In this case I might use this chapter that lists a series of building techniques which might be useful to build this kind of, out of this box and out of other boxes, to build some gearings that mesh at 90 degrees, or to mesh other gears, or other techniques to drive, I don't know if we're gonna use something out of this, but I'm pretty sure that it will be something useful. For example, this is another very useful technique, how to get a right triangle to reinforce structures. And here I talk about snot, which means studs not on top, and which is largely used also on Lego official design. So, and in case this is not enough, there is another very, very good book I can recommend by Yoshihito Isogawa. Kudos, my friend. Which reports in terms of photographs a lot of ideas to build stuff. Well, I don't even know, maybe there is something here I could use as an inspiration. Here I have a whole section about creating wind, so I might go and check if there is something useful to create. Yeah, there are working propellers, but in this case they are dangerous because they spin very fast to create wind. This is a very, very nice book I can recommend. I will put the links in the video description about these two books, which are a bit old by now because they are published years ago. The Lego book set itself is retired, but it's still one of the most popular, I would say, robotics tool sets, because it was cheap, was not as expensive as Lego Mindstorms or Lego Spike Prime, but yet it was a set which included motors. It could be programmed, and with the help of Pybricks, shout out to my friends at Pybricks as well, you can program this hub and let the program run on the hub itself without having to keep it connected at all times to a smart device like a smartphone or a tablet. So you can put the program inside here, program it in Python with Pybricks blocks, and have it running on itself. Before starting, I want to describe an important tinkering process, which was described by Mitch Resnick in his very nice book, Lifelong Kindergarten. So the process is like a spiral. This is called a creative's learning spiral, learning or tinkering spiral. And it works like this. I imagine something and I already did. Then I create something. Then I play with it. and then I share, in this case with myself or with you in this video, or if I have some peers or some friends, I can show them what I did. In case in a classroom setting you have your mates, classmates to share the thing with, and then you reflect, and then you imagine again, and the creative learning spirals out, and you repeat this process over and over to improve the design until you're happy with it, or until the times runs out. In my case, I set here a clock to show you in real time what I'm doing today.